Yeah. Hello everyone. Welcome back to my channel. And this is a new series that is some basic concepts of chemistry. So this is the first video on basic concepts of chemistry, and I'll be giving the total content from base level to highest level, which is actually needed for JEE. Along with this, we will also discuss some questions. And this is the first video, as I have just told you. And in this video, I'm going to talk about the complete basics, like what is matter, what is the classification of matter based on the composition, what are the fundamental physical quantities of matter, and also the definition of atomic mass, relative atomic mass, absolute atomic mass, gram molar mass. So these are the things I'm going to discuss in this video. So here, let us start with the simple definition of matter. What is the exact definition of matter? So why should we discuss matter? Because chemistry is a branch of science which deals with the matter. Chemistry is a branch of science which deals with the matter, its composition, its properties. So that is the basic definition of matter. So that is the basic definition of chemistry. And it is necessary to know the meaning of matter. So what is the meaning of matter? Anything which occupies space and possesses mass is called matter. It has to occupy some space and it should have some mass. Anything which occupies space and possesses mass is called matter. Anything around us comes under matter. So water, of course, definitely it is a matter in liquid state. And table, it is matter. Chair, it is matter. Anything around us, definitely that comes under matter. And based on the physical state, matter is mainly classified into three types. Mainly means we can study the properties in that state. So what are the three states? What are the three main states of matter? If you take the first one is a solid state, second one is liquid state, and the third one is gaseous state. Of course, the solid is converted to liquid when you supply some heat. Liquid is converted to gas again when you supply heat. And of course, if gas is subjected to cooling, of course, the process is called liquefaction. That is, you will be getting liquid form of that substance. When liquid is subjected to crystallization or solidification, you'll be getting matter in which state? A solid state. But the thing is, three chapters we have for JEE. One is a solid state, we also have liquid state, and also, of course, we also have gaseous state. So complete details of gaseous state, solid state, and liquid state will be discussed in the respective chapters, right? But in this chapter, it is necessary to know the classification of matter based on composition. What is the composition of the matter? What does it have? What does it have? So here it is made up of what? So based on the composition, matter is mainly classified into two types: mixtures and pure substances. Mixtures and pure substances. What is the fundamental difference between mixture and pure substances? Very clear. Mixture, it is the combination of two or more components. Two or more components. That is called a mixture. But here, pure substance, it has only one component. One component, right? So if I give an example, it will be clear to you. And of course, these mixtures are further classified into two types: homogeneous mixture and heterogeneous mixture. Homogeneous mixture means the components of that mixture mix completely. That means you cannot separate the components from the homogeneous mixture easily. But a heterogeneous mixture, of course, it is a mixture. but the components are not mixed completely. We can separate the components from this heterogeneous mixture by hand picking and also crystallization, whatever various techniques we have, we can. So minimum 2 components are present. And if we cannot separate the components from the mixture, then it is said to be homogeneous. Single phase, there is only one phase. And heterogeneous mixture means the components can be separated. I will also give the examples. And pure substances, as I told you, it has only one component. And these are further classified into 2 types. They are elements and compounds. Elements, they have only one type of atom. Hydrogen, H2, one type, I'm not saying one atom, one type of atom. H2 is an element. P4 is an element, phosphorus. S8 is an element. Cl2 is an element. Compounds, they have 2 or more types of atoms. It's a single component. Definitely it is a single component, but that component is made up of 2 or more atoms. For example, if you take HCl, hydrogen chloride. So hydrogen is one atom, chlorine is another atom. There are 2 atoms, 2 types of atoms, right? So let us take one example, some examples here. Mixtures. Mixtures contain, I told you, 2 or more substances. 2 or more substances. And in case of homogeneous mixture, the components completely mix with each other. Completely mix with each other. If you take one example, sugar solution. You take 100 ml of water and add pinch of sugar. So what happened, that sugar will dissolve in water. Now the total, both the components will be present in one phase. What is that phase? The liquid phase. And can you separate the dissolved sugar from that aqueous solution? Definitely difficult. So therefore it is called homogeneous. And also air. Air is a mixture of so many gases. Most important gases are nitrogen and oxygen. And the nitrogen completely mix up with oxygen, or oxygen completely mix up with nitrogen. That is homogeneous mixture. Heterogeneous mixture means that the composition is not uniform throughout. Actually, they are not mixing completely. And here, if I take one example, mixture of salt and sugar, not salt in water or sugar in water. You take salt, a pinch of salt, and a pinch of sugar. So definitely it is a mixture for sure, but the components are not mixing completely. We can separate the sugar particles and salt particles. Hence we can say it is heterogeneous. Mixture of grains and pulses along with some dirt. Definitely that is also what we call a heterogeneous mixture. The components can be separated. The components of heterogeneous mixture can be separated by simple hand picking, filtration, crystallization, distillation. There are so many purification techniques, right? This is about mixtures. And the pure substances, 100% they have fixed composition, 100%. In case of mixtures, you can change the composition. For example, in one example, you have added 10 grams of sugar to 1 liter of water. That is aqueous solution of sugar. Or you can add 20 grams of sugar to 1 liter of water. The composition is not fixed. But in case of pure substances, composition is fixed. And an element, these are classified into 2 types. They are elements and compounds. Element, it has only one type of atom, one type of particle, one type of atom. The particles may be atoms, sometimes the particles may be molecules. For example, if you take a sodium, it is made up of sodium atoms. If you take a hydrogen, it is made up of H2 molecules. If you take a oxygen, it is made up of O2 molecules. These are pure substances, particularly they are elements, only one type of atoms. You can see here there are only oxygens. Here there are only hydrogens. Here there are 4 atoms, of course, but all are one category. Therefore, it is said to be element. This pure substance is said to be element, and this pure substance also said to be element. And when two or more atoms, if there are two or more number of atoms, then the pure substance is said to be molecule. That is said to be compound. So that is said to be compound. And you can see this is one component, and in this component, two types of atoms are present. Hydrogen is present, oxygen is present, and actually they are held by some attractive force. That attractive force is chemical bond between oxygen and hydrogen. There are chemical bonds. And see, this is one component. Only one component is present, hence it is pure substance. It's not a mixture. But you just see salt in water. There are two components. Hence, that comes under mixture. But it is not a mixture. It is a pure compound. It is a pure compound, pure substance. And this pure substance has two types of atoms. Hence, it is said to be compound. It's not an element. It is compound. You take another example, ammonia. Ammonia. Again, there are two types of atoms. Methane, there are two types of atoms. And here, the constituents of these compounds cannot be separated by simple physical methods like earlier, for example, sugar and salt mixture can be separated by physical methods. But here, hydrogen and oxygen, by using physical methods, you cannot separate, but you have to use some chemical methods for the separation, right? So here, this is about so here composition of matter. So based on the composition, so they are mainly classified into two types. So here pure substances and mixtures. Pure substances are two types, mixtures are also of two types. And here we need to discuss some fundamental physical quantities of matter. It's very, very important. So in the beginning sessions, these basics are very much important. And in my opinion, the basic concepts of chemistry, this is completely the backbone of physical chemistry. And here we will be talking about various subtopics, right from the basics to the highest level, which is needed for JEE. But the concepts, what you are going to learn in this chapter will be very much useful. In fact, if you are not good in these concepts, definitely you cannot be perfect in the other branches of physical chemistry also. So that's why I can say it's a simply, this chapter will be the backbone of the entire physical chemistry. All right. So let us take some definitions. Yes, I told you already, from the basics to highest level I'll be teaching, I'll be discussing. So the mass, what is the exact definition of mass? And the symbol, of course, we will follow NCERT notations, and that is M. What is the meaning of mass? Mass of any substance, it may be mixture, homogeneous mixture, heterogeneous mixture, element, compound, whatever it may be. What does it mean? Mass of a substance is the amount of matter present in it. Mass of the substance means amount of matter present in it. For example, while taking one example, I said, what do we call 10 grams of sugar, I said, right? 10 grams of sugar, I said. Of course, when nothing is mentioned, we take a, what do we call table sugar, that is called sucrose. Let it be, right? So 10 grams you are saying. So you are saying that this substance has how much amount of matter? This sugar has how much amount of matter in this example? 10 grams. So here this is called mass. So mass of a substance is the amount of matter present in it. How much amount of matter present in it? So it may be 10 grams, 20 grams, 100 grams, 1 kg, 1 ton, whatever it may be. Right? So mass of a substance is the amount of matter present in it. And most importantly, mass of a substance is constant. What does it mean? So for example, if you have taken 10 grams of sugar, whatever it may be the place, you may be on any planet, the mass is constant. Mass is constant. But another property, another physical quantity will change, that is actually called weight. But I will discuss that definition also. So mass of a substance is constant, but don't think like instead of 10 grams, if I take 20 grams, then the mass is varying. It is not in that context. It is not in that context. For example, I have taken 10 grams of sugar. You may be anywhere, that is constant, 10 grams. That 10 grams is constant. On any planet, it is constant. That is the meaning. That is the perception here, right? So mass of a substance is constant. That means it does not change with the place. That is the meaning. Mass of a substance can be determined very accurately in laboratory by using analytical balance. If you are doing any experiment in the lab, there is a device called analytical balance, and by using that analytical balance you can measure the mass of the substance. For example, you are doing some experiment and you want to take 20 grams of a substance, and happily you can measure 20 grams by using analytical balance. And what is the SI unit of mass? SI unit of mass is kilogram. But being a chemist, we generally don't use kilograms in lab. We use, of course, we do use in industries, but in the laboratory, the experiments are done with the small amounts. The experiments are performed with the small amounts. So smaller amounts of chemicals are usually we use. Hence, we express the mass of the substance in grams. When you're doing some experiment like salt analysis, anything, you take 0.5 gram of salt or 1 gram of salt, like that. But we don't say 1 kg of salt, because you are doing some analysis. For that, you need to take a small amount of the sample. So when the research is being done, generally we take small substance, right? So that is the meaning. So what is the definition? Mass of a substance is the amount of matter present in it, and it does not change with the place. SI unit is kilograms. And the weight, the symbol is W. So what is the exact definition of weight? Weight is the force exerted by gravity on an object. For example, you have taken, let me take the same example, 10 grams of sugar you have taken. So 10 grams of sugar. And in this context, this is mass, but we are taking weight. The symbol is W. Basically, weight, this is the force exerted by gravity. This is the force exerted by gravity on this 10 grams of sugar. What is the force exerted by gravity on this 10 grams of sugar? That is actually called weight. That is weight. So weight is basically force which is exerted by gravity on given substance or given object, whatever. And I have taken 10 grams of sugar, and what force is exerted by gravity on this 10 grams of sugar, if you measure, that is called weight. And this weight is equal to, generally force is equal to mass into acceleration. And the same thing, weight is equal to, basically weight is a force, mass into acceleration. So weight of the object is equal to mass of the object into g. Of course, you know, g, gravitational force, is not a constant. That means weight of m, already told you, m is constant. That means weight of the matter or weight of the object changes with gravity. So from here, I just wanted to code one point here. Weight of the object is directly proportional to gravitational force because mass is constant. Otherwise, for example, here we are on earth. So g is constant. As long as you are on earth, g is constant. In that situation, I can say weight is directly proportional to mass. You can get a doubt here. You may get a doubt. So you said mass is a constant. Yes, once 10 grams is separated, then it is constant. But for example, there is a sugar bag and I'm taking 10 grams. Next time I'll take 20 grams. Otherwise, third time I'll take 30 grams. So what I'm trying to convey is, as long as you are on Earth, G gravitational force is constant. Now, in this situation, W is directly proportional to M. If you separate 10 grams of sugar, W is directly proportional to 10. If you separate 20 grams, weight is directly proportional to 20. So what I'm trying to convey is, so whenever there is a sugar bag available and how much amount you are taking, that is mass. Since you are on Earth, gravitational force is constant. So that is the difference between weight and mass. But we chemists, generally sometimes we use weight or sometimes we use mass. It makes no difference. It makes no much difference. And of course, in my discussion also, sometimes I'll be saying weight and sometimes I'll be saying what do we call mass. But the fundamental difference I cleared already, and you need to consider, because for a chemist there is no much difference. There is no much difference. I told you already, this is directly proportional to M. And the weight may change from one place to another place due to the change in gravity. And what is the SI unit of weight? So this is mass into acceleration. Mass into acceleration. Acceleration, change in speed per unit time. Of course, instead of this, you can say Newton. So kilogram, meter, second to the power minus 2. Instead of that, you can simply say Newton. So that is the difference between mass and weight. And the third fundamental quantity, that is volume. Volume. So the amount of space that a substance or object occupies. See, let me take the same example. For example, you have taken 10 grams of sugar. So sugar, it is a crystalline solid, and you might have seen there are so many small crystals, white colored crystals are present in the sugar. When 10 grams of sugar is taken and if it is placed on table, and all the sugar particles present in that quantity will occupy some volume, will occupy some space, will occupy some space. For example, 10 grams of sugar you have taken, let's assume, and there are 1 million small particles, 1 million. Let's assume nothing wrong, 1 million. And all those particles, 10 grams of sugar, that is placed on a table. And all the particles of 10 grams of sugar will occupy some space. That is called volume. So here, the amount of space that a substance or object occupies, how much space it is occupying, that is called volume. And what is the SI unit of volume? Meter cube. SI unit of volume is meter cube. But generally, meter cube is a very big thing. So we take generally the small quantities. In chemistry labs, smaller volumes are generally used. Hence, volume is usually expressed in centimeter cube, decimeter cube. Generally, we don't use meter cube. 1 meter cube is equal to 1000 liters. So in labs, we do experiments with very small quantities. Hence, we frequently use centimeter cube and a decimeter cube. And in the laboratory, volume of liquids or solutions can be measured by graduated cylinder, burette, pipette, etc. I already told you right from the basics to highest level, but the only thing you should have the patience to listen completely. So how to measure the volume of liquid? Because we generally perform reactions with liquid solutions, and how to measure the volume means we have graduated cylinder, burette, and also pipette. And of course, this is the interconversion. It is useful in other branches also. And if you take 1 liter, if you want to convert that into milliliters, 1 liter is equal to 1000 milliliters, and 1 milliliter is equal to 1 centimeter cube. So 1000 milliliters is equal to 1000 centimeter cube. 1 liter is also equal to 1 decimeter cube. And in place of deci, if you write 10 power minus 1, it becomes 10 power minus 3 meter cube. So this is about volume. And one more important property we have, that is another physical quantity, that is density. Density. Density of a substance is its amount of mass per unit volume. Definitions are important. Mass per unit volume. For example, I have taken, same example, let me take 10 grams of sugar I have taken. 10 grams of sugar I have taken. And when all the particles of 10 grams of sugar are placed on a table, let's assume these particles of 10 grams of sugar occupy, only for the sake of explanation I'm taking, 20 centimeter cube. Nothing wrong. Let's assume 10 grams of sugar occupies 20 centimeter cube. We have to convert this into density. What is the definition of density? Density of a substance is its amount of mass per unit volume. Per unit volume. Per unit volume. That means 20 centimeter cube volume is occupied by 10 grams. 10 grams. Then 1 centimeter cube volume is occupied by how many grams? If you calculate, that is called density. And of course, you do cross multiplication. And after doing cross multiplication, 20 centimeter cube into density is equal to 1 centimeter cube into 10 grams. And ultimately, you will be getting density is equal to mass by volume. Density is equal to mass by volume. And here, what is the mass in this context? 10. And what is the volume? 20. So 10 by 20, that is 1 by 2. So in fact 0.5 gram per centimeter cube. So the SI units, of course, kilogram meter cube, kilogram per meter cube. But of course it's a quite large. So we use generally the smaller units. Hence in lab we generally use gram per centimeter cube, because the experiments are performed with the small quantities. Temperature. What is the exact definition of temperature and what are the various scales we have? So the degree or intensity of heat, the degree of heat present in a substance, the degree of it, 10 grams of sugar I've taken, what amount of heat is present in that substance? The intensity of heat, the degree of heat present in a substance or object is called temperature. And how to measure it? For example, we human beings, our body has a certain temperature. Air has, atmosphere has some temperature. Any object, it has some temperature, some amount of what we call heat. What intensity of heat, what degree of heat is present in an object, that is called temperature. And in order to measure temperature, we generally have three different scales: degree centigrade or degree Celsius, Fahrenheit, and Kelvin. We generally use, chemists, we generally use degree centigrade and Kelvin. But of course, since NCRT has given the information, it is my duty to discuss. And of course, SI unit is Kelvin. And generally, the thermometer with the Celsius scale, if you take, it is calibrated from 0 degree centigrade to 100 degree centigrade. If you take any thermometer, Celsius scale thermometer, the values are from 0 to 100 degree centigrade. And what are these two temperatures? In this 0 degree centigrade is the freezing point, and 100 degree centigrade is the boiling point of water. A normal, what do we call, thermometer, if you observe, the values are from 0 degree centigrade to 100 degree centigrade, where 0 degree centigrade is the freezing point and 100 degree centigrade is boiling point of water. And the Fahrenheit scale is represented between 32 degrees to 212 degrees Fahrenheit, 32 degrees to 212 degrees. And these two temperatures, again the freezing point and boiling point of water respectively. This is the freezing point, 192 degree Fahrenheit and 212 degree Fahrenheit. And what is the relation means? This is the relation, and of course my suggestion, wherever you get formulae, each and every formulae you have to write at one place, and more number of times you have to revise, then only you will be successful. After understanding the concept, you should have a short note on it, and formulae particularly you should give the more importance after understanding, and those formulae you have to keep in your permanent memory, then only you will be successful in solving the problems. And similarly, if you want to convert degree centigrade into Kelvin, you have to add 273.15. Of course, freezing point of water 0 degree centigrade, this is in Kelvin and this is in Fahrenheit. Room temperature 25 degrees centigrade in Kelvin scale and Fahrenheit. Human body temperature is 37 degrees centigrade and this is Kelvin and Fahrenheit. Similarly, boiling point of water is 100 degrees centigrade and this is in Kelvin and this is in Fahrenheit. So here, these are the complete basics. These are the complete basics, and let me end this video here itself. And in the next video, we'll be talking about atomic mass. So what is atomic mass, relative atomic mass, absolute atomic mass, gram atomic mass, gram atom. In case of isotopes, how to find the average isotopic mass, those things and also the problems we'll discuss in the next video. And as I told you before start of the video, very clearly I mentioned one point, right from the basics to the highest level, every point mentioned in NCERT, and also what is actually needed for JEE advanced. NCERT means, of course, for mains and NEET, and for advanced, what is the additional things required. Everything will be discussed in detail. And let me end this video here. Thank you very much.